What up, dudes? Alright, let's get this party started. I'm going to be talking to you guys about a few things. I built your final exam. Your final exam has, I believe it's like, I don't know, like 60 questions or something like that. It's got a lot of questions, and they're all multiple choice. Here's my hint to you. Your final exam is built using ACTs from the last 10 years. So what I did was I went through all the ACT questions, and I basically covered everything that you need to know for the last, or everything that we covered in class, but the ACT version of it. So if you guys want to know what questions are on your test, look at the last 10 years of ACT questions. Alright, anyway, I'm going to make up this lecture, and hopefully it goes pretty fun. I think that the first thing, what I did was this morning I went through all of I went through the entire test that I wrote, and I kind of looked up what are the topics I want you guys to really know. This is something that I don't think we covered directly in class, but I think it's very important. So let me start off with exponentials. And exponents. That's what we're going to cover right now. All right, so exponents. Let's see, if I have something like x to the 5th power times x to the 3rd power, that's equal to what? Alright, this is one way you can think of it. If you have the same base, actually Elijah's already got it, it's x to the 8th power, exactly. If you have the same base but different exponents, you can just straight up add the exponents. I mean, if you kind of think about it, x to the 5th power really means x times x times x times x times x. X to the 3rd power is x times x times x. And what am I doing to both of these is I'm multiplying all of them. So if you count out the number of x's you have 8 of them. Alright, got that? That's the rules of adding exponents. If you have the same base, different exponents, you can add them. But, on the other hand, if you had x squared times y cubed, what does that equal to? Well, that's x times y times y times y. You can't multiply the x's and the y's, so you can't write it as xy to the 5th power, which I guarantee you I've seen people do it all the time. Don't mess it up. Don't screw that up. Different base, different exponents, there is no rule for that because you can't do anything to it. Are we cool with that? You guys remember this? Is this like jogging your memory? I didn't teach it in the class because I figured you guys covered this at some point in your lives. Let's see. Negative exponents, you can have x to the 5th power times x to the negative 3rd power, and that's equal to, well, if you have the same base, different exponents, you can just straight up add them, and so you have x squared. One way to think of that is you think of x to the negative 3rd power. Whenever you have a negative exponent, you deal with it like this. You can make it into a positive exponent, but basically anytime you have a negative exponent, it takes the, if it's in the, it turns it into a fraction. If it's in the numerator already, then it moves it into the denominator. If it's in the denominator, it moves it into the numerator. Let me explain to you what that means. You have x to the 5th power. This x to the negative 3rd, I can keep it as x to the negative 3rd in the numerator, which is on top. Or I can put it in the denominator and make it x to the positive 3rd power. Does that make any sense to you? You guys recall this, right? This isn't like abstract completely. Alright. You can think of this as x, 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 and then you can think of the one on the bottom as x, 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 and then 3 of these guys on top, it cancels out by 3 of the guys on the bottom, so you have x squared left over, 2 of them left over. But really the point that I'm trying to make with this is that if you see a negative exponent, you basically reciprocate it. If it's on the top, you put it on the bottom. If it's on the bottom, you put it on top, and then you can make it a positive exponent. So like, for example, x to the 5th power divided by x to the negative 3 power, that's actually x to the 8th power, because you can think of it like this. This is x to the 5th power times x to the positive 3rd power, because I took it from the denominator now, and I moved it into the numerator, and I made it a positive 3 instead of a negative 3. Are we cool with this? Is this This is familiar stuff to you, right? This isn't like crazy stuff. This makes sense to you? All right, good. So let's write that rule down. So this is adding exponents, here's subtracting exponents. I think one way to think of this is, what is x to the squared to the third power? If you're taking an exponent and you're bringing it to an additional exponent, in this case what you're going to be doing is you're going to be multiplying these exponents. You can kind of think of it like this. X squared cubed is the same as saying x squared times x squared times x squared, right? These are the same. So this comes back to this rule where I have the same base, different exponents. I can just add up all of these exponents. That's equal to x to the 6th power. Or 2 times 3 is x to the 6th power. When I take an exponent and I'm bringing that whole thing to an additional exponent, I multiply those exponents together. So there's rules for adding exponents, subtracting exponents, and multiplying exponents. Now what about dividing exponents, or exponent fractions? Alright. I think the best way to kind of think about this one is this. The square root. Have you seen this symbol before, the square root? Of course you have. Alright. This is the same as x to the 1/2 power. It means to take the square root. Whenever you have a fraction as an exponent, you take the square root of it. Or not the square root, but whenever you have a fraction or to the 1/2 power, you take the square, you have the square root. This right here is called a cube root. It's basically asking you what times itself 3 times. So like what times itself gives you a number. Like for example, what is the cube root of 8? So what times itself gives you 8? I'm going to wait for your answer. 2, exactly. There we go. 2 times 2 is 4 times 2 is 8. So the cube root is, you understand what the cube root is. If I write that as a fraction, that's x to the 1/3 power. So I guess your question can be to me, well, why don't we have a 2 out here? If this 3 means you put it to the 1/3 power, then why don't we put a 2 out in front of the square root and make it to the 1/2 power? And my answer is because we're lazy. No, I'm serious, that's the answer. Anytime you have like 4th power x, you have x to the 1/4 power and all of that kind of stuff. But we the square root, this one comes up so often that we don't even write it. And then we just assume that it's a 2 there. It's kind of like saying y equals mx plus b, and if I have like y equals 3x, or no, not 3x, but y equals x plus 4, or something like that. What is the slope of this line? Well, it's 1. Why isn't there a 1 there? Because we're just so dang lazy to write it. We don't even write it because you assume that the 1 is there. Right? It's such common, it's not such a common thing, but in this particular case, you assume that the 1 is there. You don't need to put a 1 out in front. It's just a matter of writing it. So, whenever you have something to the fraction power, you turn it into a square root, and vice versa. If you have like the cube root or something, you turn that into a fractional exponent. All right, are we cool with this one? You guys like this one? All right, and then the last one I can think of is maybe x to the 0th power. It doesn't matter what x is. Anything to the 0th power is equal to 1. And I kind of feel like that might be just a rule. Actually, it's not just a rule. It makes sense, but I don't have it's not that I don't have the math skills. I haven't taught you the math skills to be able to really decipher the rule for now, so for now just kind of accept it. And I really hate just following an equation and going, look at this. But for now, just kind of accept that anything to the 0th power is equal to 1. You know what the crazy thing is? Even 0 to the 0th power is equal to 1. I know, it's crazy. But anything to the 0th power is equal to 1. Can I think of an example? Can't think of an example of how to explain this best to you. Can we just accept this as fact right here? All right, so I'm going to write down these exponential rules, and I'm going to write it a little bit differently. I want you to write this down on your notes. Instead of writing numbers, I'm going to put m and n. X to the m times x to the n is equal to x to the m plus n. This is adding exponents. Cool? Subtracting. X to the m times x to the negative n is equal to x to the m minus n. Where m and n are numbers, by the way. All right. Fractional exponents. No, negative. Speaking of x to the negative n, x to the negative n is the same as 1 over x to the positive n. We cool with that? Multiply. X to the m times x to the m to the nth power is equal to x to the m times n. And fraction. X to the 1 over m is equal to the mth root of x. In fact, I can probably even do it this way. X to the n over m is equal to the mth root of x to the mth power. All right, this one's a little bit more general. And then my last rule is x to the 0th power is equal to 1. These are your exponential rules. They're very important. Yeah. I just want to, and actually, I feel like these might be review for you, so how about it? We cool with that? You guys can understand this? Did I make sense here? Did I speak crazy? All right, good.